Hi there, my name is Timothy Wells. I worked in the McNamara lab during the summer of 2020, and here's my presentation on the research I did towards the development of new electrocatalysts for hydrogen gas generation. So the focus of this lab and its research is towards the development of iron complex electrocatalysts for the generation of hydrogen gas through artificial photosynthesis. Hydrogen gas has a huge potential as an alternative fuel source. When it combusts, it breaks into oxygen and water, which makes it a zero pollutant fuel source. Super cool. Also, it can be simply made through water, sunlight, and the electrocatalysts like the ones we've been developing in lab. So it can be done rather cheaply. These electrocatalysts are complex that are structured around a metal ion. This ion normally is something like platinum. However, platinum is rare, it's expensive, and it's not very viable for widespread use. So that's why in our lab, we have been trying to develop iron-based ones because iron is much, much cheaper than platinum. So in order to do this, we had to review the current literature of the field in order to get a better idea of how to design the complex around the metal ion. Of the people I reviewed, I found the work of Daniel Du Bois was very beneficial. Daniel Du Bois is an internationally recognized expert in metal inorganic catalysts, and his thoughts on the structural characteristics necessary or helpful for enhancing catalytic ability was very enlightening. From the papers that I found of his, I found several features that would be helpful when looking for catalyst or complex structures. So first of all, a small binding angle between ligand constituents enhances catalytic ability, as well as nitrogen atoms near the metal will stabilize the bonds around it. Substituents with high electron donating ability will also be helpful in enhancing the catalyst ability to help in a reaction, and having similar hydride acceptor abilities between the metal ion and the ligands that are around it will also be helpful in enhancing catalytic ability. So using these guidelines, I was able to hone in my search for procedures for ligands. So what I found that I could synthesize once I returned to lab and then complex them around iron. So this is the one that I settled on at the end of my summer. And I'm very excited to see how this one turns out. It's a hexadentate ligand. And I think it's got a huge potential for working for catalysis for this generation of hydrogen gas. My name is Tim Wells. Thank you very much for listening.